Engage your safety squints. So I spent the past few days using this thing as a CNC plotter, just doing some basic drawings to get myself acquainted with the CAD CAM process and the machine itself. I've done some CAD in the past, but they've all been very basic designs for 3D printing over there on the Lulzbot Mini. This stuff is something new to me. It's a different kind of machine, different workflow for making the G-code, different system running the G-code, and most importantly, it's the first time I've made a machine from scratch. So there is some learning to do. And overall, there definitely are a few quirks that I'll show you on these drawings here in just a minute. But I'd say I am pretty pleased with the quality I'm getting so far from this build. There's like a million different things here that are a little bit janky. Between the hot rolled steel for the gantry, the skateboard bearings for linear motion, all that, and it adds up. So I'm not so sure where these errors are coming from, but I will go into that more in another video. And if any of you got comments or feedback or suggestions, I'd appreciate it. But on the whole, I'm pretty happy with it. It's definitely better than I can draw. As for the CAD and CAM that got me here, I made these designs in Inkscape, which is an open source vector graphics drawing program that happens to have an extension module for generating G-code. Now I used Inkscape because it is a simple program that lacks features and really has a number of bugs. But anyway, because it's simple, that makes it easy to learn and just get something done, right? All I'm trying to do here is draw some geometric shapes and get ink on paper. Nothing fancy. Kind of the same way I use Gerbil for testing my wiring. Once I had all the crimson stuff done, I put Gerbil on an Arduino and just sent some pulses to the motors just to make sure they work. Simple is good for testing. Now, long term, I'll probably end up using FreeCAD for all the design and G-code generation. Now, I've used FreeCAD a good amount in the past, but only through the CAD query workbench, which is an interface for Python scripting. So when I want to make a 3D printed object, I write a Python script, like code, to build that up, then export it, and then I load it in Cura, the slicer, to actually make the G-code for the printer, off of the printer, and away it goes. But I find that easier because I'm a software engineer. So to me, writing code is simpler than clicking through an interface and menus and all that kind of stuff. Your mileage may vary. And I will say in the past year, FreeCAD has come a long way in terms of the CAM offering in the program, specifically with the Path workbench. I think this came about for the first time in a usable way in version 0.17. And now in the 0.18 pre-release, it's pretty impressive. It has a lot of features for an open source CAD program. And from the testing I've done with it, seems like it'll work just fine for my needs. And even for mill or lathe or whatever as I add more tools to my shop. Now I have not put any of the G-code from that on this machine yet. I've just made some simple models in there, tested that I can actually make G-code and run the simulations. And overall, it worked pretty well. If you want to learn more about that, I'm going to put video links in the description below, where another user on YouTube named Subtonic gave a pretty thorough tutorial on how to use it. And that was from just a few months ago. So it's still on a pretty recent version of FreeCAD, and everything it covers there is still applicable today. And he also has a few other videos giving an end-to-end demonstration of how he makes something using FreeCAD and his CNC laser, which is very similar to what we're doing with the CNC Plasma. And to top it off, this guy is one of the primary contributors to the Path workbench in terms of the code written. He's one of the developers who works on it. So Subtonic is a guy to tell you about that and how that all works. So I'll let him do it. Links below. Now, I'm going to try to avoid jumping on the Fusion 360 bandwagon for a couple of reasons. First off, it only runs on Windows and Mac. It doesn't run on Linux. And everything I own is Linux. I don't have anything else. Why would you run anything other than Linux? I don't get it. So that already makes it dead on arrival for me. Secondly, I'm not a fan of the cloud. I prefer things running on my computer locally. Call me old-fashioned, but I prefer things to run local. When stuff's in the cloud, it just means at some point that program will get shut down and then it's gone forever. Especially if it's a proprietary, closed source licensed program, and especially if you're paying for that license, I expect it to run locally on the computer where I have ownership of it and where it can't be taken away. As a matter of principle. Now, I know that Fusion has a very, very, very generous free tier in its license, but it doesn't change the fact that you don't own the program, and at some point that can be changed or taken away, and I'm just not a fan of that. Next up, right now I'm using Inkscape because it's dead simple, right? Easy, get it done in like half an hour, got up and running, easy. Next I'll be using FreeCAD because it has more features and it's more complicated and all, but it's worth learning that, okay? Fusion is a program for professionals. I am so far from being a professional. I don't need to learn all the different features and tools. It'd be nice, but I don't need it. And when I went through just a list of tutorial videos for Fusion 360 and like tallied up all the things I'd want to watch to learn, things that I think I would need, it was like 130 hours of video. And you know what? I know your product's great. I've seen other people using it and it looks fantastic, but I'll pass on that. Lastly, if I end up using FreeCAD, that also has programming APIs, which again for me is important. And a lot of it's written in Python. So if I do find bugs and stuff, I'm at least halfway decent with Python, and it gives me a chance to, do bug fixes and add features and maybe help make the project a little bit better. So very different reasons than I'm sure most other people are going to have. But for me, I'm not going to go the Fusion 360 route. Your mileage may vary. So this first one here was supposed to be a triangle, a few hexagons, a couple of circles, and then a square with a spiral in it. And you can see that's not what I got at all. So I did this in Inkscape, made the G-code, all looked fine, loaded it in Linux, looked at the preview on the machine controller, that looked fine, and then hit play, and then this came out. And I was just like, what? But I had a hunch that it had to do with the velocity in the trajectory planner, because these corners here were coming out round. Like that was the weirdest thing, right? Like the square here, this corner came out square because it's where it started. This triangle, square here, but when it came in the corners, it rounded it off very steeply. So I lowered the feed rate a good bit, hit play again, and then got it with less rounding over. It's like, okay, that's the right direction then. So I went back and added a couple of sleep statements in there after linear motions, just adding I think G04 is the sleep command, and I just added in the G-code by editing it manually in a text editor, and sure enough then, I got real points on my triangle. So with that knowledge, I went back to the Linux CNC docs and looked up the trajectory planner to kind of see like what was going on here, and it turns out that indeed there's a G-code for that. G64, I think, is what you use to tell your system that the G-code is naive and not accounting for trajectory planner and keeping the position versus the acceleration versus the velocity and all the accuracy. So using G64 in the future, I was able to tell it, value the position more than the velocity, and then things came out better. The things you learn, right? This one turned out way better. The hexagons here are hexagons, but there's still a couple of issues. I don't know if you can see, but the corners here don't touch all the way. And then the lines between them should have a small inconsistent gap, but instead they have an inconsistent gap, okay? And the circle is a bit more than tangent to the square, kind of coming in there where it should just barely touch. And then on each of these spirals and the circle at the parts here where it's most straight in Y and just a little bit of motion in X, you can kind of see some waviness. So all that kind of struck me as weird. The waviness I did eventually figure out was, again, the feed rate. It's a bit too high for the pen, because the pen is just, there's a lot of play in the end of a ballpoint pen. And too high a speed makes it wobble as the Z is moving slowly and the Y is moving fast. Because that stepper for the Z making small motions causes some vibrations that go through the gantry and then affect the tip of the pen. But I did plenty more tests and couldn't figure out, and still haven't figured out, the cause of the misalignments on these hexagons here. So I went and made another design instead, a bunch of circles and more lines, see if I can repeat it, and sure enough I could. So you see right here, if I come from the origin and make that line, it's where I expect it to be, but if I come down and then up, then it's coming high, and this angle here is less than 90. So it seems like there's some difference in the X position, depending whether my last Y motion was this way or this way. And for reference, I'm calling the gantry this way Y, and this, the axis, is X. Just a convention of picking myself. You can set up your machine however you like. Anyway, more of that here. Then I went way overboard, added a lot more lines, saw this corner here where I repeatedly came from different directions was all sorts of wacky. And then again, I had the same misalignment down in here. And then I had the idea of repeating it at different parts of the table. That way to see whether it was, that position, like that part of the axis is a problem, or if it's something more, around about the table in general. And then when I went to the middle of the table, it just got worse, way worse. So you can see here that these circles don't even come anywhere near being closed. And this is also all sorts of off. And then down here, we still have the same angling issues. So tried it again, same thing again. And lastly, moved to the back corner where suddenly things were perfect. So up here, it was meh. In the middle, awful. Back corner, pretty great. So when a friend asked me, like, what are you going to do to fix it? I was just like, I don't know, I'll use the back corner more. The goal is I can find out what the problem is eventually and fix that. But for now, I'm not so sure. I'm just trying to, process elimination, figure out what exactly the issue is. So when I did the first image again in the back corner, I did have one part here where the ballpoint pen just skipped because, cheap ballpoint pens, but everything else came out right on point. Like that's the line I wanted to see, the little gap right there. These things come together, the circle, just barely tangent there. Still a bit of waviness from the speed I kept up, but yeah, this is what I want to see across the whole table eventually. Let's see, then I moved it closer to where we are right now, and then it also came out pretty good. So here was good, over here was simply okay. So there definitely is something that depends on position, and also depends on the way the y-axis is moved. Then I did a few that consisted only of diagonal and orthogonal lines, and sure enough, got the same repeat sloping issues here as I was traveling along the y in that direction. So I still need to retest this in a position of the table that I have previously found to be good, such as this one right here. So let me set that up and give you a demo of the machine up and running. Starting off the box. So I didn't take as much care to align it this time to get the grid underneath the pen, but close enough still to see what's going on generally speaking. Okay, so it's a little bit off. Yeah, just the same way it was when I redid the first set of prints down here. Not as bad as it was over there or in the middle, but still just not fully right. Damn. And there we have it. So still a little bit off to these lines here. So while I continue tuning the positional accuracy of the machine, I still have a few things left to install, namely the limits and homes, the e-stop, a control cabinet, proper grounding for the cabinet, the torch mount, the water basin, the slats, the Z-touch off, and torch height control. I thought CNC was supposed to make stuff easier,